This is a conversation with Maria Telleria, who is a co-founder and the CTO of Canvas. Canvas makes a drywall finishing robot for construction sites. One thing that I think is especially interesting about Canvas is that they are working closely with a trade union. In case you don't know, quoting from the AFS-CME, a large trade union in the US, a union is an organization formed by workers who join together and use their strength to have a voice in their workplace. Unions help workers negotiate for better wages, benefits, and job safety, among other things. I'm not very knowledgeable about unions, but my impression before this interview was that unions often slow the adoption of new technology in a trade, and I think most robotics companies I've talked to avoid or try to automate unions out of relevance. So I was surprised to hear how Canvas is working closely with a trade union and that both Canvas and the trade union seem to be benefiting from the collaboration. In the future, I expect to see more robotics companies following Canvas's lead, since I think working with unions can help robotics companies understand their problem, get into industries much faster, and avoid resistance from people already in the trade. At the same time, I believe unions can benefit from automation. In Canvas's case, their drywall robot helps to reduce the rate of repetitive injuries that end people's careers, and they help a trade that is significantly short on people to meet their demand. I'm Audrow Nash. This is the Sense Think Acts podcast. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Maria. Hi, Maria. Would you introduce yourself?
Yeah, hi, I'm Maria Telleria. I am co-founder and CTO of Canvas, and we're a robotics company bringing drywall finishing robots to the construction industry.
Mm-hmm. Now, tell me about your drywall finishing robot.
Yeah, so when we come from a research background, and we've been always looking at why aren't robots used in other, or they are used, but not really widely used outside of manufacturing and logistics. And right, I think is a challenge that probably many in the audience know, that construction environments are much more difficult for robotics. And so my co-founder, Kevin Albert, and myself were always driven by like, hey, let's bring robots to another place. We got fascinated by construction, right? The size of the market is huge, the problem. But then, you got to keep digging, and that's where we found drywall finishing. And we picked this task because it is particularly painful in terms of like a lot of wear and tear on the body, a lot of like repetitive steps, a long schedule, even if the work is not consistently being done because you have drying steps. So really the goal was like, okay, this seems to have all that, dull, dirty, dangerous for robotics. Let's go at it. And so, yeah, our robot is, I keep saying tool because it is really meant to be an augmentation of the worker. So we do have a worker in the loop. They are a key part of the component. They're a key part of how we actually solve this problem of the unstructured environment. Mm-hmm. But it is, this robotic system. It's a robotic arm with very specialized end effectors that allow it to spray on the joint compound, which is what you apply on the drywall sheets to cover kind of the seams, mm-hmm. and then a sanding end effector that sands it down so that it looks smooth. And that robot arm is on a mobile base that allows it to reach all the different places, mm-hmm. in the construction site.
Gotcha. So what does it look like when the robot is actually doing its spraying and sanding? You kind of just position it near a wall and it goes and slowly covers everything with its arm, or how does it look?
Yeah, I mean, maybe this is where picture's worth 1,000 words. So
sure,
let me go ahead and pull up a video to show you. Let's check go full screen here. This is pretty much a quick peek, but I'll describe it as we go, right? Mm-hmm. Really, started with the idea that there is a lot of construction going on, but this is what the job site looks like when we come in. It has been taped, so you have to apply this tape between the different drywall sheets, but you come in and you go ahead and install that spray end effector that you see there. Mm-hmm. A big part here, I'll pause it to talk a little bit about it because you mentioned you position it. The key part for us is we have to build our map, mm-hmm. to make this happen, right? We don't have a map when we start. There is things like BIM models. So BIM models, the building information model, it's kind of like the CAD of construction sites, right? they do exist. They're pretty detailed. They have everything. Them rarely by the time we come in are those that accurate because nobody's updated and we're like, things had to move a little bit. You kind of make that decision as long as not something structural. People can move a wall a little bit because of whatever reason happened on site. So one is not accurate, and two, they don't often get shared all the way down the chain of people who are working, right? They're kind of more used in the design and modeling stage rather than in the build stage. So most of our customers just have a floor plan, so a 2D plan, and they say, right, I got to finish these walls. So one of the key things that we implemented was that, well, we can't depend on them having a BIM model, excuse me, and we can't depend on the BIM model being accurate, so we're going to have to map ourselves. So basically the robot comes in, right, scans the space, identifies the different areas that it has to treat, and then a key part here is that it splits them up into workspaces, right? This goes to the fact that the robot arm can only reach so much, right? Just like your arm, at some point you have to use your legs to move along. So by splitting up into these workspaces, we really think of the mobile base that you see there as a pretty big base, positions it roughly into the spot, and then the robot arm can use all of its precision to go ahead and target it and apply. Here you see our operator select the workspaces, the rows, columns that he wants to do, and then you see how it sprays the material, and we apply this very consistent code across it, making sure that we target the low spots, and then by the end of it, right, you have a full coverage of your machine. This part we can touch on later, but one of the hardest parts with construction is reporting back of what's happening, right? A lot of the problem is when work is done manually, you have to kind of call people up and get kind of an update on what happened and really report them back. I think that's one of the secondary effects of robotics and logistics and manufacturing is that you also get that data for free. So we're just showing a little bit of what's possible here. When the robot's in the loop, the supervisor can get updates that are live and they're very accurate. And then the next day, same robot arm, mobile base, different end effector. So we put the sanding head on, comes in, it uses the same map that we created the day before, and it starts sanding away. And this is, again, a lot of our development has gone around the sanding because it is a very soft material, right? If you reach out across your wall, you can scratch it with your nail. It's a soft material that you need to make it look really flat. So you have all of these things that you have to work around to make sure that you get that nice consistent finish. And this is, again, talking back to the data reporting that you can get back. This video is a little old, I think from 2020. So this says 25 projects completed, but we're now in the more like 40 plus range.
Oh, that's so exciting.
We've been doing.
Awesome. The video was very informative. Hell yeah.
Oh, good.
So let's see. What exactly does the operator do?
Yeah, so I think the operator really does all the things around it that allow the robot to be successful in a unstructured and dynamic environment, right? So they do things like selecting which areas you want to skip, right? There might be a reason that you don't finish that right then and there. They can provide feedback to the machine as well on the quality so that the machine can tune and get that feedback process from it.
Yeah.
They're also doing a lot around coordinating around with other trades, right? So the reality is the electrician's also in there, the floor guys coming in, the painter's right behind you, so that coordination with all the different people. But in reality, they really are the ones that at the end of the day, they're the quality assurance, right?
Gotcha.
They make sure through feedback or even sometimes a little bit of manual work to ensure that the final goal is so that the machine really takes 90% plus of the brunt of the work, but they're the ones who are skilled who have this. So our operators are tapers, they're journeyman tapers who've been trained in this skilled, and so they can pick up a tool if they need to, like a manual tool, and fix up anything. But more importantly, they have that eye and that training to say, okay, this needs a little bit more here, a little less there. Okay, that's how you get a wall to look flat.
Yeah. So you said they're called tapers. So that's the construction role, like job role for someone who would do this. It's really interesting to me that you are having the person who would do this normally be the robot operator. Can you tell me a bit more about that?
Sure. Yeah, and I'll expand a little bit on they're called tapers because you string this paper tape across it. So, right, that's where the name comes from. Their union's more the drywall finishers is kind of the more, I guess, formal term, but everybody in the construction side would be like, oh, the tapers are coming. Yeah. So it's, construction, they end up getting down to the point. You string tape, you're a taper. But yeah, to your point of like why, right? Because we could have gone a lot of different ways, but as we really thought about it again, to ensure that we get that quality finish, we needed that expertise, that skill level. And there's going to be things that may never make sense for the robot to automate, right? Imagine somebody decided to make like a Gothic column out of drywall. You could do it. I don't think I'd want to spend the time programming it because we'll never see it again, right? But a worker has that years of experience, that delicate touch, that adaptability that a robot doesn't do. And so, hey, I'm going to start the robot here, finish the brunt of my work, and I'm going to use my skills where it's really needed, right? To provide that feedback or to finish some delicate part of it. And for us really to be successful there, you needed somebody who could work with the robot, right? So it's like, oh, we have this great, skilled, talented person. We augment them. That's the way to go, right? As opposed to maybe bringing in somebody who's like a robotics expert. Okay, maybe the robot kept running, but I'm not sure that wall would look very nice at the end of it.
Yeah, for sure. Okay, that's so interesting. And so what are some of the challenges? So if you brought in a robotics person, the robotics person may not know anything about the wall, but can keep the robot running, as you're saying. But so if you work with a taper, then like what have been some of the challenges of working with the taper? Kind of bringing the robot to the craft instead of the craft to the robot is what it seems.
Yeah, that's a really good way to put it. And it really is making it super easy to use, right? And so because we want their time that they have, right, where the robot's running autonomous to be doing other things, like we said, coordinating, tackling tough spots. So it's really about like, make it like a tool, right? They learn it, they do come to a training in Canvas, but after that, they should just keep on running, right? It shouldn't be asking them things in a robotics manner, right? Like, would you like to increase your workspace, right? That might be a little bit, or like, hey, your inverse kinematics failed to solve, right?
Yeah.
Like that would mean something to them, but something like, hey, what's the quality look like to you, right? And that's more, I guess, specific example. For example, we wouldn't be like, is the thickness, 1.2 millimeters as specified? That's not what it works, but we could say like, hey, do you think this needs more material added, right? Are there low spots? Are they high spots? That's language that they know, that then we can translate into, okay, they said there was low spots. We got to build up more material here, go from 1.2 millimeters to 1.4. So I think it's a lot about translating things to the words around them, that the craft words, if you will, that make sense. And then really making sure that your robot is a tool, right? Not something that has to require programming. We also have created kind of on-site support within the user interface. So when they do run into these problems, which they might, there's somebody just on the other end to keep them running and to do that kind of debugging that you'd expect a roboticist to do.
Gotcha. So what does the whole setup look like in terms of even the infrastructure behind the robot? Like, I guess it gets to a bit of the business model. Is it like you lease the robot to a company and then you provide the service, or how does it work?
Yeah, we are doing a leasing model for the customer. So they come, they get trained, they train their operators, and then they lease the machine, for year-long leases, and then they have different projects that they would move it. We help them with the logistics of moving the machine since it's something new. But from the other part, right, they pay per day, and then they have access to all of the support around it. So they have remote support that they can call. That's usually what they would normally use. But if something really big did happen on site, there's also people from Canvas who can go and support them on site and help them, if there was a problem, if needed. It's very rare, but it is something. Right now, we're only in the Bay Area because one of the things we wanted to make sure is like be really successful in a small radius, such that you can ensure that your customers get that, work out the kinks, keep them running.
For sure.
Actually, when we first started, we did the service ourselves. So we became drywall subcontractors.
Wow.
And hired tapers onto our payroll and had our own people running it, right? And that was really important because for the customer, it was like, I'm excited about the idea of a robot. I'm not really sure how it's going to work for me. So we said, fine, you buy drywall at $1 per, certain dollars per square foot, pay Canvas the same amount, and we'll get it done, right? We just happen to have robots that do it with our operators. So that was the first 2-3 years. Once they saw it working and really saw how it works, and they're like, oh, okay, this works into my workflow. They started saying, okay, now we want to run it, right? We want to scale up with it. So that's really the transition point we entered around the middle of last year, is really saying, okay, the robot's at a state that you guys can run it. We'll rent it to you and we'll help you make sure it's successful.
Gotcha. That's really cool. So it sounds like it was extremely iterative to get to where you are now. Would you tell me a bit about that? Like, so now I assume you guys are somewhat of drywall experts, but like you have this problem and you think it's going to be a valuable, good, big value add kind of thing. And then you start in this way that you were talking about, where you work with the contractors and you basically become the contractors, but hire people to man your robot,
Hmm.
and then growing that to the point where it's like useful enough that you can just give it to the contractors to do themselves. Like, just tell me a bit about that whole process.
Sure. One of the big things from the beginning has been test on site as quickly as possible, right? So
Hmm.
the very early test, like, I mean, probably now I'd be embarrassed to call that a robotic system, but you know, you had a robot arm.
Yeah,
It had to be moved manually.
like a cart.
But
Yeah, a cart with
exactly,
a
it was
robotic
the
arm.
cart.
That's so funny.
Yeah, one of my team members was much stronger than me, so he had to
Yeah,
come to
they're
every
heavy.
site because he had to position the robot. But it was a way to your point, right? We were like, on paper and in the lab, there's a lot of value.
Hmm.
But we all know that the real issue is the site.
Doing it.
So we took out that, cart with the robot arm, demonstrated that, and then kept iterating, right? We were like, okay, we can't hire, just a person to move the robot. So we ended the mobile base and
Hmm.
all of that. But with that, we did learn a lot about drywall finishing itself. But even before, very early, when we were like, we're going to do drywall finishing, we're like, yeah, let's hire somebody who knows what good drywall finishing is. So we
Hmm.
brought on team members who, years of expertise, who, journeymen, journey people themselves who just been trained in that skill. And Hannah sat, next to them and really said, okay,
Wow.
how do we get to that level? The really interesting part there, right, is that we were both learning from each other, right?
Hmm.
Because people have optimized this trade incredibly, right? Sanding's the worst part, so they've optimized it to reduce the amount of sanding. And
Mm.
then, so when we first brought them in, and what I think a lot of people think with robotics is like, okay, well, let's do what the person does. But we wanted to take a step back and be like, your constraints are different, right?
Yep.
Sanding, robot doesn't care. It'll sand or
Yeah.
it'll spray, whatever you tell it to do, it'll do it. And so if you remove that constraint, maybe you approach it differently. And so you saw the video, we apply all of the material in one go and then sand more versus a person applies it day over day, slowly building up the profile that they want to get and then just sands a little bit at the end. So
Is that so it dries? Like you keep letting it dry so it dries very evenly because you do like thin layer after thin layer where each layer can be quite even and therefore the whole thing appears even?
yeah, it
And
really
then
is
minimal
more about
sanding.
that minimal sanding, and you need to use kind of the datum, right? So the sheets kind of look like this. There's a gap between them, and use the edges to apply the material, but then that shrinks and
Hmm.
as it dries. So then the next day you come in with like a little bit bigger, and you use the next datum, and this is how people do it, right? Because they need a
Ah.
reference point, they need to touch the wall,
Yep.
and it means, to your point, they have to make thin layers. They have to wait till it dries, even though maybe they're done for the day, and they're like, oh, I wish I could apply the next coat. Because
Hmm.
it's wet, you can't do anything. So as we looked at it, we're like, well, robot doesn't need that data, right? It has this really good map around it. It can spray material very consistently versus a person, right? Imagine trying to move at zero point 0.1 meters a second for 8 hours a day. Might be a little hard.
Yeah,
And so
gosh.
it was sitting with each other and being like, okay, you guys do it this way, but you're also really good at adaptability. You're also getting the world's best feedback control
Yep.
system through vision to touch, right? The amount that they gather through their touch is incredible. And then we
Hmm.
said, well, robots don't have that, but they have really high repeatability, right? And they don't get tired of sanding. So we said, well, then let's make the process a little bit differently. Let's make a process that the robot can be successful at, apply all the material at once, and then sand a lot, but you're really using the things that the robot is good at and not depending on what people are good at.
Gotcha. So I imagine during this, there's a lot of like picking the brain of the tapers, and your roboticists really try to understand kind of like what's the whole process, what's actually being done, not just the way that they do it. So you're not trying to recreate what they're doing. And then from there, you try to then optimize for what's best with the robot, given the way that the robot behaves and what it's good at and what it's not.
Exactly. Yeah, I think that's the right way to think about it is like, what are you trying to accomplish? Not necessarily how, but let's start with what are you trying to
Yep.
accomplish? And then we can work out the how. And the actually are the people we hired, Teresa as our superintendent, she came with all this experience. And one of the first things she was like, you guys have to tape yourselves. It's like, yeah, all the engineers out there would tape. I don't think we've passed her quality standard yet, but she lets us run the robot.
Yeah.
She won't let us touch it. But it
That's-
was a little bit of like, yeah, understand why you're doing it. And it was seeing those things and understanding that we're like, oh, okay, well, that would be difficult for a robot. But what you're trying to do is create this profile. Okay, well, there's other ways to create a profile, right? If you don't have the same constraints.
Can you tell me some of the difficulties about spraying and sanding that you guys came across?
Definitely. In the spraying side, right, that consistency. That pump delivers about 3.5 gallons per minute. So it's a lot of material coming pretty fast, and you have to apply it fairly consistently. So that all sounds, robot can do that. The problem is more, I guess, upstream, if you will. The materials that have been developed so far have been for people. And so they're not very tightly controlled materials, right? The viscosity varies widely, which when you're assuming that you have the same viscosity and you get the same result.
Bad assumption. Yeah.
Exactly. Big problem but from the manufacturer side, they've always had the person in the loop. People like their own, viscosity, so they add a little bit more water or a little bit less. So it's for them, it's also not worth it to optimize to a certain thing because people are so variable, right? So that was one of our biggest challenges. We're working with a material that is not designed for robotic, right? Imagine the paints that go into painting your car. I'm sure there's very little variation when they go into that paint shop, right? And then the robot, sure, does its thing and it's going to be great. We were working with materials that weren't designed for that. So we had to think a lot about like, how do we close the loop on that? And again, hey, how do we use the operator who knows that to help us close the loop? So they help us a little bit with preparing the material to the right one, but also providing that feedback if it's going well. And so I would say that's the biggest challenge with the spraying is the material itself and modeling that.
So how does it work now? The person gives you feedback on how it is, but do they do some prep work to make it so it's like a fairly consistent viscosity, or what kind of thing?
We give them some guidelines, but they do have to, the material comes in is a little too thick for spraying.
Yep.
And so they have to thin it down with some water. But this is where we've seen right at the beginning, we're like, only add this amount of water, and that's where they provided the feedback. They're like, this varies a lot. So then we started being like, okay, let's be more descriptive. Get it to this type of consistency, right? Makes me think of the baking shows with like, get it to the stiff peaks, but different.
Yeah.
So we started being more around that, like, okay, what we really need to do is to get it to this consistency. And then they use their own feedback system to be like, oh, well, this batch was a little bit more liquid. I'm only going to add half the water that I normally do. Or this batch, and it's actually temperature dependent too. When it's really cold, the material
is very thicker, difficult.
So
exactly.
Everything that could be different about it, our process team. So I was like, come on, everything is variable. And we need to develop a process that achieves the right result, even with all that variability.
Have you ever, I'm sure you considered this, but I'd like to hear your thoughts on it anyways. Did you ever think of working with the manufacturer of these materials to try to like get them to control it pretty consistently so you could, I don't know, work with it more easily?
I like where your head is at. We have, and they've been really great. I think they also see a place where introducing robotics also allows you to maybe improve on the materials because, again, your constraints have changed. So they've been great. We've been working with them since the beginning, really. But you also have to manage that with like what's already acceptable on site. So, we kind of did it in parallel, said like, let's work with, again, as few barriers as possible for our customers. So no map, no this. But hey, let's also develop this side because there is a future where, we could all have a better result. So that's happening. Yeah, they've been great. I think they also see the vision and especially their scientists get excited, right? Because all of a sudden you're like giving them a new design space. The design space for people is this. The design space for robotics, like, you wanted 1.3 millimeters thick? Done. We'll do that for you. And then, well, then we can do all this.
That's so funny. Yeah, it is interesting. It's so interesting to consider when you change the constraint space. Like you were working with people are really good at certain things, not good at other things. And now you take a robot totally good at different things and bad at other things. And so it's like, okay, you can use the best of both. And this is very interesting. It's an interesting spot to be.
Yeah, they get excited. They're just like, oh, I've had all these ideas. Let me go after it. And even also
so cool.
the constraint space of cost. Because it is a very labor-intensive task, the materials budget, if you will, is very small, right? It's all of the costs has gone to labor, especially as things, get harder and harder. It's just, and so with the materials manufacturer, we've also had that conversation of like, hey, maybe you can have a little bit more expensive material. If it gives you more productivity,
Yep.
that works, right? And so they also start seeing the idea of maybe there's greener materials, or materials with better end properties, right? What if we could have better sound absorption in your drywall walls? Or you get into really cool spaces once you start opening up that space. And so I think we're really excited for that future where robotics coming in also change some other of the upstream assumptions.
Yeah, it's so interesting. So if you can almost, like if you take this to the limit where you have like infinite robots flying this and all the drywalls are, so then you have the robots already, and then it's basically free to have the robots do it other than like the cost of energy and transporting them and this kind of thing. And then maybe like really nice, highly optimized materials, and then the materials cost rises, but the total cost even like would be less because the robot would be effectively free labor. That would be very cool. I like where the like new potential optimization space, or I don't know, space you can optimize. That seems awesome. Huh.
Yeah, for us, we will always have that operator in the loop. So it's about their costs because they'll be there in their time, spreading it over more square footage, right? If I produce 1,000 square feet in one day, that's something. If I produce 2,000 square feet, now there's that room for the materials. There's that room for that optimization. So no, I think that gets pretty exciting for us, and it also protects themselves where they can have a longer career while working with better materials and better things. So it's kind of this win-win by really thinking about that augmentation, because it's about how much can that person produce rather than replacing them. That's not necessary. It's better to augment what they can do. Right?
Yeah, not necessary and probably not even possible too, because you need their expertise. I was thinking it's a little bit like the grocery store model, like where you have one person manning 10 registers or this kind of thing, but it's also different in that the person is highly, highly skilled, which puts it into an interesting space.
Yeah, that's a really good analogy. I think this idea of like I can supervise more, but my job does change. Right now, they're much more technical in it. They're much more customer success, right? Making sure that they're making these things. So it's kind of how things evolve. But if you completely try to remove the person, I think most roboticists would say, "Oh, that gets really hard." Yep. Why not utilize them with their best, right? Utilize their adaptability, their smarts. We don't have to wear down their shoulder to get this work done.
Yes,
right?
it sounds awful. For sure. So with this, how has the building climate, like economic climate, been? In that, like I've had several interviews where there's shortages in people to do different work. Is there a shortage of tapers, or is it like, does this let you stretch a taper to do what 20 tapers could do, or like is there a big shortage there also?
Construction is facing an incredible shortage, across all trades. Taping is definitely one of them. Is 1 in 4 tapers has to have shoulder surgery.
Oh, that's so bad. So,
yeah, and those things, right? They maybe fix it, but it's never the same, and so they often either have to retire early or live with that pain, which is
and it's because of the sanding. They're like incredibly
mostly the sanding, that repetitive motion on your rotator cuff, right?
Oh gosh, yeah.
Ceilings also really hard. There's also dust, which the sanding
people
part,
breathe it in.
I said, exactly. They optimize to reduce it, but it's still there. And even if you're not sanding that much, the tools that they pick up, are 10, 20 pounds, and they're doing this
it
all
for
day.
8 hours. Yeah, that's crazy.
Yeah, your body just wears down on you. And so as you really, think about that, it's been really hard for like the union, who we work very closely with, to recruit new people. And you can see that, right? It's like, it's actually a really good paying job. Like I said, it's amazing the skill these people have. But when you put them in front of like, maybe you'll retire at 50.
Because your shoulder will be blown out.
Because their shoulder, exactly. And you'll definitely be hurting, at the end of the day, you're going to have a long day. And you're just, so I think it's hard for them to bring in, and they've told us themselves, right? We're having a really hard time bringing people in. And even with the people we have, there's a lot of work, right? We have to double building stock, and there's just not enough people. The shortage in construction is just outstanding.
Yeah,
And so how do you bring new people in? And I think that's giving them tools. So then you are excited to do that work. It's like, oh,
for
great.
sure.
I can protect myself. And then also for those people that you do bring in, getting more done.
You're letting them be like craftsmen with underlings kind of thing. It's like the apprentice model, but the robots are the apprentice in a sense that does some of the work. That's really
Yeah.
cool. What do you, so just curious on your perspective on this. So do you think it's the more skilled jobs that are harder to fill, or the less skilled jobs in the construction industry? Like, is it the tapers, or I don't know, the general construction worker that, I assume the shortage is in both, but are they kind of, is it more in the taper area or more in the general worker area?
That don't know exactly, but my sense is in general everybody's having a shortage, but you see it in those harder on your body operators. So I think they all have like our journeyman that we work with is I believe a 4-year process to get trained. So it's a long apprenticeship. Similar electricians have their apprenticeship, but the wear and tear is not equivalent across trades. So I think trades like drywall finishing in particular suffer from that. Like, well, if I'm going to pick a trade, I might pick one that is not as hard on my body, or even, we're in a different time, and, people see like our controller and they get excited, right? This is things they've grown up with. It looks like an Xbox controller. It's a robot. So there's also that like engagement of like, I'm working with a really cool tool. So I think between that and making their day-to-day just be a lot less painful, it's the right way to bring people in.
I imagine it's like because I imagine that they got into it because they enjoy it somewhat, like the meticulous attention required for this kind of task. I imagine, like, I mean, I love programming, and it's like the same kind of thing, I imagine, where it's, I enjoy the details of it. And so I can imagine them enjoying the details. And in this case, they love the inspection, they love going, this needs a little more of this, and then the problem solving that probably goes along with it that I don't understand what it would be. But so you let them do that, but you let them delegate all of the repetitive work to the robot. That seems really great to me.
Like you said, the pride that the people have on their work is, they love, I created that. Your wall looks amazing, right? There's those walls, they call them light walls, where you have like the skylight that shines on it is glossy when the architect really went all out, and to get something like that looked beautiful. So there's a ton of pride in a lot of our feedback with them, working especially on the user interfaces. How do I give you that ability to use your craft, to use that and get that engagement, right? Because they do want to keep that in. There's, they want to keep that pride, that skill, 4 years of training, you want to show that you're that person. Not everybody can do it, right? So even if I gave you the robot, we could easily get you trained probably faster.
Do a terrible job, almost certainly.
But I don't know that the wall would look that great.
It's like a giant hole in it. It's like, no, it's good other than that. Yeah.
Just put the picture frame in front of it. That's all I get.
I know. That's the plan over there in the wall. So, that sounds very funny. Okay. So what other challenges did you have with, so spraying, the big challenge was the viscosity. Were there big challenges with sanding as well, or was that kind of straightforward?
No, sanding's really where we started with our research days, because sanding requires contact in the surface, right? A lot of the, robots started a lot in welding. That was nice because you have that little bit, like, I don't have to be perfect. As long as I can get the arc across it, good enough, right? And then, of course, you say, well, control everything around it, and then we're going to get there. But the moment you needed to sand, you needed to have that contact. And it's not just, the, distance to the wall, but like your angle of approach and that soft material, as I was mentioning. So that was a lot of our work, was like, how do you make this sanding head without a perfect map, right? We do map our own space, but you're going to get
there's still
3
variation.
Centimeter accuracy, right? Yeah, so that's
3 centimeter.
Quite a bit.
Okay, that's pretty big for a precise job.
Yeah, exactly. And so part of that is just your approach,
right?
We don't want to be mapping all day.
Probably not much more than 3 centimeters.
Yeah, it's about, now I'm going to go into inches, but like 1/2-inch drywall, it's very common that I would put up.
Yeah, so that's 3 centimeters or something, 2.54 or whatever it is per inch.
So you might not be, right, you don't know exactly, it's plus or minus. So really about thinking of how do you approach that wall where I have a good guess where it is. I have a good guess of the angle that it is,
Yep.
but I want to make that really soft contact, right? Because I can scratch it, I'm going to create more damage. So this is where our research came back to compliance. We really thought that one of the ways to get robots out into the world is make them compliant, right? They don't have to have a perfect map as long as you can tolerate that in by doing compliance. So we built a ton of compliance into our sending end effectors such that you do your best to get the best map, but then you say, at the end of the day, I'm going to have to, at surface, the reality too, like the joints will be like a hump or a dip, and you don't want to like fault or cut through that hump. You actually want to ride it out. That's what people do. It's never flat. It's just the illusion of flat. So you also needed your sanding head to kind of ride that hump and like spread it out. So that was a lot of work, and we had like 4 years of research with the government before even doing this that we were able to leverage.
So what do you mean compliance in this? Is it like springs, or do you mean like what do you mean by compliance, I guess?
Yeah, in general, we look at it achieving it whichever way you want, right? A spring is a perfect example where it allows you to absorb that error that you had in positioning. Exactly. So we look, there's springs, dampers, but also on your control side, how do you detect that compliance and react to it so you don't have to have all of your compliance be mechanical. Some of it can be coming in from your control system.
Gotcha. So do you do a mix where you might have something, so you have the sanding head and then you might have something where it can kind of move a little bit, given like with a spring, I don't know, keeping it kind of facing forward, but like giving a little bit if the wall is a slightly different shape than you expect. And then you do it in hardware or in software too, where, and that's you kind of do you emulate additional springs in the motors, or what kind of approach is that?
Yeah, there's a few ways, but one could just be, enabling or sensing that mechanical displacement, if you will, that you're having, and then utilizing your software to give you a larger range, right? So, for example, if you're coming in like this and you're already detecting, but you're going to hit your hard stop, you go ahead and like tilt your arm to compensate.
I see.
So, some of it is more like a feedback, but there's other ways, right? How you run your control system around it, allowing it to, be tolerant, right? My ultimate goal is not perfect position. My ultimate goal is perfect force, right? Constant force. Also on our control system.
Your goal is constant force. That's really useful for sanding? Interesting. Okay.
Yeah, this goes back to that hump where you want to ride those out and like apply the right force to level it out, but I don't necessarily want to grind down a hump because that's going to get through the other side of drywall. One of the big challenges is it's not just the drywall, but it's how it was hung. So if somebody didn't hang it very well, you have that, and then how it was framed.
Yeah.
So all of a sudden you start like
there's a lot of room for error, for sure.
Yeah, they're the ones who fix everybody's mistakes. So we have to come in and fix everybody's mistakes, and it's true, right? It's accumulation of error that then you have to
then they refine
build back.
Interesting.
And so you need that that approach of, let's smooth it out, not necessarily flatten it out.
So if you have a hump in your drywall, so it's hanging and there's a hump, and you're trying to apply a constant force throughout it, now what I'm thinking, if you had a point sander, like then it would just make everything deeper, like shorter into the material by the same amount. But because you have a sander that has an area and you move it around, it kind of averages everything out, and that's why constant pressure is important. Is it correct? Or
yeah, that's correct. Yeah, and then you also have to look at having your compliance also in your tip tilt so that you can kind of also ride out that in both axes, right? You want to be able to adjust.
Yes, definitely. Axes. Yeah. My explanation was 2D, but yeah, totally 3D.
Yes.
For sure.
Yeah, multiply it.
Yeah. I imagine the same thing holds true in 2D and 3D for that. Okay, and how do you get your initial map for the robot?
Yeah, we use a LiDAR system to create our map, and then from the point cloud, because this also has to be fairly fast, right? Anytime that you're not running the tool is not productive time.
For sure.
And so from the point cloud, find the planes and then work off of those, subdivide them into spaces. So it's a little bit, it's a different application, right? So much work around LiDARs and point clouds, but what are you trying to do with it? For us, is finding surfaces, right? As opposed to maybe identifying objects like maybe an autonomous car has to do.
So is it like a person carries around something, or do you drive your robot by it, or how does it work?
We drive the robot by it, so the operator
Oh, it's
comes
easy then.
in.
Nice.
They have a little like do a little loop, and they get some feedback on the user interface if we're getting a good map, and then they also get to once it pops up, they can use again their smarts to say like, "Wait, I'm missing a wall" or something like that. They can correct that.
Gotcha. Was that part pretty straightforward, or was there challenges there too?
Yeah, I would say definitely feels more straightforward because it is mostly a technical challenge, and
Yep.
sometimes I get excited when we find just technical challenges.
Yeah, it's like because it'll be one thing that's relatively easy and fairly established too,
Yeah,
for
and
sure.
don't get me wrong, right? It took a lot of work and optimizing and getting it right, and we're all
Oh,
always
totally.
still tuning and stuff. But it is something that like it's well within our control, and
Yep.
probably one of the it's a little bit of a challenge, but also exciting is the technology advancements on the lidars has been incredible from
Oh,
the time we
totally.
started. So a lot of it has actually been like, okay, should we upgrade to the next lidar? And
Ah.
that means retuning our mapping algorithm, and so playing that trade-off.
Yep.
But yeah, I like those challenges that are mostly technical. Not that the
For
other
sure.
ones aren't interesting, but definitely when you're trying to change people's perceptions or
Oh, totally.
construction business alignments, you're just like, well, that's a lot harder of a challenge.
Oh, totally. I think to me, it seems like successful companies are founded on just a few very hard challenges, like one or like two or something like this, as you're sanding and spraying. But if it
Mhm.
was like every single thing is an incredible like moonshot, then it probably wouldn't be a good long-term bet for the company because one of those moonshots will be a giant bottleneck for this kind of thing. So it is nice when you
Definitely
have just an
agree.
engineering problem.
Definitely agree. And the way we think about it is like, let's make sure you're successful with like just those 2, 3 challenges. They're big enough.
Yep.
And then we talked about material development. That's great,
Mhm.
but don't depend on that, right?
Oh,
Because
totally.
it's
Make it
feasible,
work
but it
now.
probably has a longer timeline. But so we work on
For
kind of
sure.
this research on the side, and as those kind of get proven out, we whoop, and then it moves
Yep.
up. But you kind of keep this team running on more researchy stuff.
Yep. And it's almost like a parallel thread too to the main
Exactly.
value add for the company. So it's like we're going to be around in 10 years and like then maybe that'll kick in. And we can have these conversations now, but they're not like you're not waiting to be a profitable company before for that to work. It's like, hey, we got it. We can just make do. We have to mix it to approximately the same consistency, and it's all fine. This kind
Exactly.
of thing.
Yeah,
Gotcha.
make sure you provide value at that point to the
Yep.
customer, right? Because they're like, "That's great that you're going to do that in 7 years, but
Yeah.
I have a project tomorrow. What can
Yeah.
you do now?"
And venture capitalists are like, oh,
Those
7
jerks.
years you think you'll start to be it's like, oh, it's a robotics company with all the infrastructure and funding that requires. Yeah.
Exactly. It
So
is definitely, yeah. That's where I think you really want to show this an ability to get on
get
site
it done.
sooner, and so having those things, and back to where we began, where it's like keep the person, allow them to do that, help you get to that place, right? And that's why
Mhm.
it's both, I think, the right way to do it from our values, but also the right way to do it when you look at the problem. You're like, okay, let's do that. Let's keep the
Definitely.
person in there and help us get out there.
Uh-huh. And so I'm torn between two segues for this. The first one, so how are you, so I mentioned just a little bit with like venture capital and this kind of thing. How are you guys funded?
Yeah, we're venture backed. We raised our Series B about a little bit over a year ago,
Mhm.
and so it's been great. We previous to that, like I mentioned a little bit, was we were doing research for the government, so we did
Yep.
have some NRE dollars. So it was a great way to develop the idea. Back to your point,
Oh,
back then there
totally.
was too many problems, so research was a
Uh-huh.
great place. So we worked with NASA and Office of Naval Research. They were really looking at this, compliance in this spaces. They're the most unstructured of spaces. So then we said, okay, great, we solved some of that
Constraint. Yeah.
in construction, much better. And yeah, once we really found that application, that was another decision for us. It's like the Swiss Army knife of robotics. It's pretty hard to do, right? Trying to
Mhm.
solve all those problems. So we knew we couldn't just be the construction robot that did everything. We said, let's find one trade, one task that
To
we do
focus
really
on.
well. Yeah, and then from there we can expand. And so
Yep.
once we found the task and we had demonstrated that there was value with the current technical challenges as opposed to future, that's when
Mhm.
we went and fundraised our round and then did a follow-up round in 2020.
Gotcha. That's exciting. Oh yeah. Um, Can you talk a little bit about kind of bringing on investors and the process of that? Because getting really savvy investors can be a huge benefit, but getting ones that have like incredibly draconian clauses and their funding agreements can, I've seen it kill several companies. So I assume you guys are doing fantastic. Like it sounds like things are really good. But would you tell me a little bit about kind of picking the right investors?
Yeah, I think a big challenge is when you're hardware, you're already probably looking at a different space of investors, right? At least here in the Valley, it's like there's so many investing firms, but you should research what they invest in, what are their theses, right? If
Yeah.
they've never done a hardware company, let alone a robotics company, they might not be the right fit. And early on, we talked to everybody, and then very quickly you realize, oh, you guys are used to software, like and only software. And maybe that's, you guys are great, but do we really see, like, are you set up in a way where your fund can support something like, right? You wanted them to have secondaries because we know this is a longer process.
Oh, totally.
That you,
What do you mean
yeah, that you want,
secondaries? I don't
where
know
they
what that
can,
refers to.
it's kind of like they can come in and reinvest in the future round. So,
Oh.
like, have you reserved, they're putting X amount into your first round. Do they reserve some amount? They don't have to use it, but do they reserve some amount so that when you're raising your next one, they can
Also put
reinvest
additional
and put
money.
it in?
That's
Yeah, and
smart.
it's just a
Yeah.
nice way to support that. I think it just shows that they've thought through, like, look, this is not going to be a one round hit, right?
Mhm.
We're going to have to develop. It's just the nature of hardware. It's a huge, awesome win, right? The defensibility is much higher, but it is a longer path. So a lot for us was really a search problem, right? Find those
Mhm.
people who understood us, and then to your point of like kind of that relationship, who supported the company we wanted to build, but also brought in maybe the areas that we weren't so good at, right? And provided that guidance and really served as advisors at the same time.
Mm-hmm. Now, so you mentioned you have like 40 jobs or so done so far. So I assume this means you don't have that, maybe you probably have less than 40 robots with this, which make me think less than, like it's not a manufacturing problem really for you guys because it's kind of, so this is interesting to me because it changes possibly the type of investor that you would want to get. Would you tell me a bit about this?
Yeah, that's definitely a big challenge, right? There's two things. The way that we're looking at it is creating a lot of value with one machine. So we're not going to be a consumer electronics volume, right?
Yeah.
Where it's like little value, but hey, you sell, 10 million of them, you're doing great, right?
Yeah.
It's a much different approach. It's much smaller volumes, but create a lot of value for that. So that already changes your perspective on how you're going to manufacture, right? You're not
sure.
talking thousands of units to your point, right? We're talking tens of units now and then scaling up from there. It's your design space changes from when building it, right? There's maybe manufacturing methods that you don't have as high access. You might, you can't injection mold every piece. You have to come up with another way because, every mold is so expensive. They're like, how many do you want? About 20. You'd be like, wait, what? 20 million? No, just 20.
Yeah, they're like, oh, 20 million. That sounds great to us. And they're like, no,
that's
20.
a great deal.
Yeah.
Yeah, slow it down. So it just makes it a little bit, and so it just comes again to, can you create enough value, and then your product have the lifetime to support it, right? Because it can be an expensive product, but if it runs over the lifetime and brings in the revenue, you can actually have very good payback periods, and that's been a metric for us. Like, hey, make sure this robot pays itself back within a year, and then you have a five-year lifetime.
Yeah.
That's a good business model, right? As opposed to maybe it could be something cheap, but if it only brings so little value. So I think you really have to look at payback periods to see if your hardware has the right thing, and then work with your design team to say, all right, how do you get a good cost, well, without access to maybe the cheapest manufacturing methods that are out there?
Definitely. Yeah, it's a totally different problem for this. And you can also kind of embrace that it's not going to be like the one-off thing and try to get it so you can make 10 of them at a like not very well, or not as optimized as possible to be the lowest cost, but then you're focusing on kind of the longevity of it, and then it pays itself back, so you can invest a little more. How do you so I'm just wondering, and maybe I'm a bit naive with this, how do you, with robotics being fairly new and things coming out all the time, like you're getting a robotic arm, maybe it's fairly well established, maybe it's not, and then some of the LiDAR. How do you predict how long something will last? Is there like this kind of thing is an interesting problem to me because I don't know that every part would have a track record for many years.
No, you're 100% correct that not every part has it. Some parts do. Our mobile bases, actually, we retrofit a construction base. So these things actually work for like, I feel like you find them 30 years later, be like, oh, it's still working. Maybe change the batteries, right?
Yeah.
So it is kind of going through your components and then also build your model to be realistic. Those things that you're not super sure about, or maybe sensors that maybe they do have the lifetime, but do you actually want to keep it for 5 years and be using that old technology?
Or the company could die and then it's like you have to support it and they had a closed proprietary sensor driver that you can't access for this kind of thing. No longer works on Ubuntu 2026 or whatever it will be in a couple of years.
That's right. And so what we found is I build that into the models. Those that either we're not so sure that the lifetime will be those 5 years that we target, hey, just build in that there's going to be replacement parts, or the ones that we're like, we're not sure we're going to want to use this. Either company's not stable, or, you know, there's a much better sensor. Why would I still be using, you know, 5-year-old LiDAR technology when I can get this one? Then you build that into your model and say, hey, there's going to be so many thousands of dollars of replacement parts that I do over the lifetime. Do I still get a good payback period, right? Does it still pay itself off if I make those changes? But of course, you also don't want to be changing them every minute just because it's a better sensor. You got to make that ROI analysis per component. But do your best and then keep really good track, right? As we're out there, we've been running now for almost 4 years. So
it's so exciting.
You know, the machines are still going, so that's good. But you also have to keep track what things did you replace. Was there any leading indicators that could have told you that you needed to replace that before a true failure? So, you know, predictive maintenance is like this awesome future that, you know, manufacturing and logistics already has for so many cycles, but we're making sure to like collect the data now, even if you're not sure what you're looking for. Later, if you have a failure, you can go back, oh, but the torque was increasing, right?
Yeah,
the temperature was heating up a little bit more. Yeah, what was my leading indicator that would have told me to replace that?
That's so interesting. I've never really thought about that. I like that perspective. You kind of gather the data and then and you just like preemptively are gathering it because perhaps you'll be able to see trends in the future and it's probably fairly cheap to grab now. That's really cool. Yeah, and I guess manufacturing and logistics probably has that down. But that's very cool for you to apply to your systems.
Yeah, I think some years ago, maybe the data would have gotten expensive, but now it's so cheap that sometimes we're like, do we need all this data? But it's worth it to keep it and then look back. And there has been some things where we've been able to kind of look back and be like, oh, okay, we saw that here, we saw that there. All right, this is starting to be at least something to look out for, right? And we put maintenance in the way to service our customers right after every job. It comes in and gets inspected. And so we can at least check for those things, you know, and identify those areas that, okay, maybe built into the model that, you know, batteries will be replaced. So let's go ahead and adjust for that in the cost.
Gotcha. Now, this question, I don't know if it's too early, but I wonder what you're thinking around these lines. So in my understanding, when you take venture capital money, they're typically expecting an exit. I hear like the timeline they say is 10 years, but it's often a lot closer to 5. I'm wondering, and so there's several different types of exit events. You can be bought by someone, you can IPO, or you can, I don't know, there's other things too. Where do you think, do you think you'll have, what kind of liquidation event do you think you guys will have at some point? And I don't know. What are thoughts around that, I suppose?
Yeah, our plan around that we've always thought is like build a successful company. So build with the goal of IPO or something like that in your mind. If you're doing that successfully, the other liquidation events can also happen. And then, yeah, exactly, it's your deal. I think when you build to like acquisition, you get into a really tricky spot, right? Where like you're now trying to guess what they want, or you built yourself so much into them, and then they're like, actually, we decided we don't like robots anymore. Like, so our thought has always been, be a sustainable company, right? Build a company that's, you know, at some point you stop taking venture capital, you can produce your own things, right? We want to expand. Drywall finishing is our starting point. We want to expand and really be that tool that you just know that, oh, construction, you use Canvas, right? That's the tool that you use to make everything. And so make sure that your models and your plans are built to a point where you do have that feature where, you know, you can support that R&D and the new product lines off of what you're
To
earning.
keep growing
And
and
then-
keep building. I see.
Yeah, and then if that way it's under your control. You're building what you want to build, and it should mean that all your liquidation
Takes care of
ways
itself.
are possible, right? Exactly.
You're basically aiming at the one that gives you the most option, in a sense,
Mhm.
by being such a compelling business, as opposed to overfitting to one customer buying you, or I don't know, or I've seen people or companies be bought when they like miss a funding round or something like this kind of thing. But if you stay competitive and keep growing what you can do and stay profitable, I mean, that sounds fantastic. And then you'll be in a wonderful situation to like get the best investor and all this other stuff. That sounds wonderful. Oh yeah,
Shoot for that.
for sure. Yeah, it's just an interesting thing because it's a trade-off in a sense with venture capital, as opposed so you get to grow quicker, but you are on their timeline to some level because they are expecting some sort of event where they'll be able to get their money out for more. And so just working with that.
That's right, and that continued progress towards that event, right?
Mhm,
And so, like increasing valuation with rounds. No, it's definitely a decision that you have to make and look at. And
For sure.
yeah, like you said, speed. They definitely have what you need if you want to go fast. You just got to make sure that
Yep.
you can deliver, and you look each other in the eye and you're very honest of like, this is what we'll
That's
deliver. We're looking, we talked about building that successful company. What's your time frame? What's the timeline? Do we all agree that that's a reasonable timeline, right? Had they been like, in a year, you have to be
I know.
everywhere.
They're
It'd
like,
be
we said 5 years, but we meant 2. It's like,
exactly.
we want a unicorn immediately. Yeah.
And that's a perfect one for us with the expansion, right? We knew, having been in robotics for a while, like staying in the Bay Area was the best way for us to move really fast and iterate, right? And we knew if we started shipping these across the country or the world, we're spreading ourselves thin, and now you're dealing with operational problems as well as technical problems. So it's like, why not iterate here? The market is big enough here. And so we laid that in front of our investors from the beginning. Like, look, we're not going to be that grow everywhere quickly.
Nope.
Because
Just
we're not there
nail
yet.
it. Nail that one area.
Yeah, exactly. Nail it, and then almost have the customers be like, "I
Begging,
want you
"Come
come in
over
here."
here.
Yeah, exactly.
That'd be wonderful. Yeah, that funded growth would be fantastic. When they're like,
Mhm.
we have a big project over here. We need you over there. It's like, I don't know. It's logistically challenging for us.
How much?
Yeah. Oh, that sounds
Yeah.
wonderful.
And then we can support it, right? Then your support team is not 8 engineers that have to be
Totally.
in New York, right? You've
And
set
flying
up your remote
everywhere all the
support.
time. Yeah.
Exactly.
I'm always
We
surprised
have
when I
our
see
predictive
early
maintenance.
companies doing that. When they're like, we're here and there and there and there. And it's like, there's 10 of you. It's like, how? But
And that has been the approach I think that a lot of firms, venture capital firms, have pushed. And for some models, I think it makes sense, right? The first at the market is more
true.
important than anything. But when you have hardware, I
Yeah,
just
it's
haven't
hard.
seen it be that easy. Yeah.
And it's logistically a lot of challenge to coordinate. I mean, you have to so even if you're not going to fly one of your skilled engineers there when the robot is down for some reason, it's still like, okay, now you need to train a few very highly skilled technicians in the area
Mm-hmm.
and coordinate with them and give them updates and all sorts of things. So that sounds hard to me. It sounds like a smart approach to stay just in the Bay Area. Hell yeah. Let's see. So now the other really interesting thing that I was thinking about with the segue earlier, you are working directly with unions with your robot. Just tell me a bit about that.
Yeah, when we first started, right, we were learning about construction. We found drywall finishing. It was actually interesting because we were thinking, as roboticists, hey, we hear drywall's painful. We were thinking of hanging the sheets, and it was talking to construction people. Were like, oh yeah, that's hard, but let me tell you, right? We don't think we had even thought about that, and it was like this perfect. That was it. As we looked at it, right, one was look at your market, right, and we just talked about it. We wanted to be in the Bay Area, stay tight. Commercial construction is what makes sense for robotics, right? Unless you have a pretty big house, maybe the logistics of moving the robot might not make sense instead of the square footage, right, that your house has to do. So we knew that there was like a minimum project size that it made sense to even move a robot for. And so that was like, okay, commercial, Bay Area, it's a union market, right? And I think that could maybe have scared a lot of people and be like, all right,
It scares me.
think about
I
another
was thinking
thing.
about it, yeah. But I also don't know
And I think
anything. But yeah.
But no, it's a little bit of the reputation, right? Like unions are hard to work with. We just said, let's go talk to them, right? Like, why assume these things? I'm sure they've have heard the things. So robots just want to take your job. So we
Mhm.
each have our biases. Let's
Yep.
just talk. And so we reached out to them and just said, at that point, we don't think maybe we had that prototype with the cart. It was pretty rough, but we were just like, hey, we don't have the tool yet, but we want to invest our time to develop a tool for your trade.
Mhm.
What do you think? And kind of like, we're like, we don't know what to expect.
Yeah.
But
How's it
they
gonna
were
go?
great. They were just like all the things we talked about, like we can't get new people in the trade. There's more work out there than we can do. And we're kind of tired of, all the injuries that we have and everything.
Mhm.
And the last piece, to their credit, they had recognized that in the past they had opposed new technology, and the result had always been loss of market share. So they're like, when we oppose certain things, we lost residential.
Mm.
And so there was also like that really nice reflection on their end of like, okay,
They're
what has
pragmatic,
happened when
it
we
sounds like. That's wonderful.
Yeah, exactly. What did we oppose? In painting, our union does both the drywall finishing and painting, even though it's two different trades. And so they had lost a lot of the painting market by opposing the airless sprayers. And so they were like, okay, we learned our lesson. Let's go at it. And then there was also that seriously being like, we want you all to be running the machine, right? We want the tapers to be the ones running. And so I think that was also like where we both were looking at it as a shared future. And then we committed when we became a subcontractor. We said, we'll sign the union agreement, right? We want to work with you all here in the Bay Area. And so they've been great. They've let us test at their facility. They have this really cool facility with all these like doors and windows, right? Because they have to train around them. And so we bring the robots, looks like, and then, so they've just been amazing. The introduction, we run user studies and a user interface with their members who maybe have never seen the robots. Like, hey, if I just showed you this, what would you think it does? So they've been really a great ally in building this and then supporting it and then getting people trained and using it.
Gotcha. So with all of the, I guess, so the union, their job is to protect the people who are in this trade. And so then you're coming to them and you're saying, well they recognize that the people are hard to find, people are leaving with injuries, they're losing share because maybe other people are coming in that are not people in this union and doing similar jobs. So then you come and you say, I have this robot, it's going to make it a bit easier for your people to be efficient, they won't get as injured. And then now you two are working, or you and the union are working together, you being Canvas. And now then there's a bunch of mutually beneficial things that are occurring that you were saying, which is like they're helping with training. They're probably helping you understand the landscape a good bit better. Would you tell me a bit about that?
Yeah, I mean, the cool thing about the union is like all of the people who do this are in the market that we serve are in the union. So we have to sell to all the different customers, right? We don't sell to the union, we sell to the people that employ them.
Yeah.
But they have kind of like the gathered knowledge of the market, right? They know which company's busy. They know which company likes what because they have to work with them on a day-to-day basis. So they do have kind of that more,
They're the hub,
if you just talk
in a sense.
Yeah, exactly. With a customer, you might get like a little bit of a bias or something, but if you talk to the hub that hears that, they sit across these 20 customers. Yeah, exactly. They can help us. Okay, we're hearing this. Help us translate that. Oh, what's happening is blah, blah, blah. Or no, that's customer specific. Let me tell you a story, right? Like the amount of background, like, ooh, yeah.
They know everything,
It's
yeah.
almost, yeah,
They've been in this world.
and then they speak for the people, right? At the end of the day, because the customers, the labor, right, is not like their employees. They pay the union wage. So they also are better to speak for the people doing the work than maybe our direct customers who are more, hey, they're part of our costs, right? People are part of our costs, but they're
Just
not
wanna get it
necessarily
done.
our employees. So I think it's also good to touch that there because if we just touch to our customers, we might miss something about the people who are doing the work, right? They're just one step removed from there.
Yeah, it's clever. It's funny because it sounds like it was initially a hard decision to decide to go to the union. Like it's like, do we just avoid them and then try to do whatever? And then it turns out to be this big advantage because they connect you to everything. They kind of let you in on this. And then it's like once you're working with the union, now everyone in the union is aware of this great thing you're doing.
Yeah, that's a very good summary. I would say the first decision was tough. I think there was a lot of people advising against it, right? Because I'm sure they've seen it not play out well or different things, or like, hey, maybe go to them once you're pretty well established, right? You negotiation table. And we just decided to go with the approach of like, hey, pretty honest, this is what we have right now. It's not great, but we see the potential. Do you see the potential? And by having that relationship early too, I also felt a little bit like there wasn't like, they would have heard about us, right?
Oh yeah.
And it would have been like this, like, hey, you're developing around versus like, no, oh, when customers came, have you heard of this robot? They're like, yeah, we're working with them. They're awesome. We're like, oh. So it also helped with our customers and even their own labor force who might be scared if they heard of this thing versus the union telling them, hey, this is why we're supporting it. Let me explain. So it also helps with those misconceptions that you have.
That's interesting. Does it, so I'm not terribly knowledgeable about unions. Is this union like local to the Bay, or is it California wide, or is it US wide, or international, or how does the union work?
It's both, right? There's the larger international, national unions, more national, but they have kind of their locales and they can run independently. So when we say working with the union, it's been directly working with the, DC 16 is that district council that we work with directly because they represent the Bay Area. So that also made it, it was like this conversation directly with each other. There's a larger, union of unions, if we will, where they all kind of report. They've been great at saying like, hey, once you guys are ready, we can also introduce you to our friends, right, and other things. But at the same time, we were like, let's not bite off too much. Let's start by this year piece. So the agreements were only with them to start with.
And as you were saying earlier, make it so they're pulling you over, like, please, bring your robot over to us and somewhere else. Okay. Has there been any challenges working with the union?
Trying to think. I think there's always, maybe not union specific, but just working with a labor force, right, that has misconceptions about robotics.
Oh, totally.
It's always difficult, right? I think there's a lot of that, why are you here? But no, I don't think there was anything specific about the union, right? The agreements get to be more complicated, but, get lawyers who understand that. So as an engineer, I don't have to figure out what a collective bargaining agreement is.
Yeah.
But the details, right, could be overwhelming if you're not used to it, but this is where getting people who understand this, what are their ultimate goals, let's find a way, right? Because that agreement, for example, didn't have anything about a robotic tool, so we had to work with them to make sure that was covered. So I would say that's maybe more work. That might be the only difficult, but the challenges around the workforce have been more general rather than like union specific, more just the misconceptions.
Yes. How do you address those misconceptions? I guess you can show them your robot, but any like I don't know, stories or approaches you found that have been really useful?
I think the best one has been not me telling them that it's okay, but people like our team who are tapers who've trained with them, explaining to them why it's a tool, why it works with them, right? I think there's something about like somebody who's lived your shared experience, who understands how tough the work is. So I can shout it from the mountains and they're like, oh, that sounds interesting, but what do you know, kind of thing.
Yeah.
Which is fair. And then, but that's why having, again, our team members, our experts be part of Canvas. One, they directly would tell us if we ever were not going in the right direction, right? They could raise it before we kind of stepped in front of everybody. They can raise it, but then when we go on site, they're usually the ones, they're most of our direct customer success in the field is our field team who knows. And so when they explain like, hey, I've been using it for 2+ years. Let me tell you what is good about it. Like, let me tell you what is not. Let me tell you what parts are, why it's exciting for me to use it. I think that goes a long way. And then of course, being able to say like, look, we're working with your union with, but what you've signed on to be kind of like this agreement of working together, making sure that we're protected. And so that also helps go a long way.
Yeah, that's very interesting. And it's funny to me, but makes total sense that they are people are in general most accepting of something when someone kind of in the same boat is like, no, this is really good. As opposed to like, I am a tech person and I say this is good. It's like someone who also does this job is like, this is great. This really makes our lives easier. Then they support it. Let's see. So So where do you see yourselves, like where do you see Canvas going in the next like 5 to 10 years?
The two big areas, right? One is expansion, like we will leave the Bay Area. That's coming sooner rather than later, right? We've tested it. It's being successful on sites.
Hmm.
Now it's time to go out there. We have we have our support manuals. We have our, inspection schedules to feel comfortable that as we expand, we're not going to be stretching ourselves thin.
Too
So
thin.
that's one
Yeah.
of the big areas in, 5 to 10 years, right? Cover the metropolitan areas in the U.S., right? New York, Atlanta, all of those at least to start, right? Where there's concentrating building.
Hmm.
And then the other area is on the, like I mentioned, I want Canvas to be the tool for other trades as well.
Yeah.
The benefit we can provide with drywall finishing, it is a particularly good trade for it, but it's not the only trade. And a lot of the challenges that we already solved are common, right? Moving the robot, localizing yourself, breaking down the task into workspaces, all of that are common to other tasks. So I'm excited by also starting to look at those other pieces and how do we, change the end effector to be able to tackle a different trade or a different task.
Gotcha. That's really interesting to you think about how to use the same platform, like basically a base with an arm, and what tasks can it do. That makes a lot of sense.
Yeah, you can start optimizing in two ways, right? One is like which tasks require the least change, and that's exciting. But you also might want to optimize by which tasks are next to you in the construction cycle. Because if I can optimize for a task that happens right after or right before drywall finishing, I don't have to move my robot twice, as opposed to maybe one that's 3 months before drywall finishing. So there's two ways to optimize, I think, and we look for that space of like not too different technically, but also, hey, I want to target things surrounding drywall finishing to start to get the most use out of my mobilization costs.
Yeah, and if there's any intersection in those two optimization problems, then you could probably do that. And that might have been what spraying was after you did sanding.
Exactly.
Gotcha. What do you, so you mentioned it, how do you handle the logistics of getting your robot to the actual construction site?
Like I mentioned, we use a mobile base, or started with a very dumb but very robust mobile base that is used in construction. So, it's a flatbed or just a truck with a lift gate, and put it into the machine, drive it in and out at the site. And then when we come in, usually, they're closed off, elevators are in place and everything. So you're just kind of riding in as if they were bringing in another man lift, as they call them, right? Because people need to reach heights. We haven't talked about that, but one of the big wins of the robot is it can, lift up to and finish up to 17 feet.
Wow.
That avoids a person having to go up and down. So it's a mobile base, a lift, and an arm that really constitutes kind of the components.
Cool.
And so, but these are common in the sense of people have to go to those 17 feet to finish.
It's frequent,
so, yeah, we move it very similar, like to that. They move this, right? The operator has the remote control. They drive it around site. No autonomy there. We just say, hey, this is complicated enough. Operator, one-to-one, move the robot to the site.
Yeah.
But hey, once you get into a space, now you can start talking about some autonomy.
Gotcha. Yeah, and it's quick enough to just have them drive around. And that's really nice that it lifts to 17 feet. Because I imagine now it's like you're hurting your shoulder through repetitive motion of a heavy object for 8 hours a day, but also you're up high. And I'm sure that as you get tired, there's more accidents occurring when people are like on a ladder finishing. And you have to like go down, move the ladder, or if you're on one of those, I guess if they're on a lift, it's a little bit different. Like one of those.
It's a little bit, they'll drive it, but in general, your productivity usually goes down to half. The moment that it's about 8 feet, because up and down, because think of the material, right? You don't have all of it, so you're coming up and down, and like you said, the moving it and injuries, that's one of the biggest sources of accidents in any construction trade is that, the moment you're on a ladder, and it's hard, right? People are tasked with, hey, finish this much by this time of the day, and so there is also a pressure to run, and so you start seeing the ladder scooting, or the, that you shouldn't see, but people
ladder scoots are like, and they bump over when they're up high.
They're actually pretty good at it, but yeah, you shouldn't do it.
I imagine like even like if you could walk on it for a little bit by tilting it back, that would be horrifying.
But it is this pressure, right, to get the productivity numbers, and so I think it pushes people to, rush through things, so it leads to more injuries versus, again, if your tool makes you more productive, there's other ways for you to hit those productivity or get a better update, right? That,
Yep.
hey, early on we're this ahead or this much behind. Let's
plan
let's
accordingly.
plan tomorrow. But even right now they have a hard time, right? Because it's so hard to track of all the work. So the boss might just be like, faster, faster, and they're actually doing really well. And you're like,
Yeah.
why are you yelling?
Yes. Actually, this goes to something you mentioned earlier, reporting. Can you tell me a bit about how your robot does reporting on the task at hand?
Yeah, I think because we have that map and we can correlate back to the work, we can report, the square feet finished. And so that already is a win. But the other part is we change the process. So we apply all of the material in one day and then sand in another day. Versus a manual task right now, it's multiple steps.
Mm-hmm.
So if you're the supervisor, you have to walk around the site, figure out, are you in step 2 or 3? And they're hard to tell, right? It takes some level.
It looks the
And if
same,
you're in
basically.
Exactly. And if you're in 3, are you going to achieve the final quality in 4? Because it's dictated by number of steps, but the reality is that they could be touch-up, right? If you're not doing a good job in step 1, I don't care, if you're in step 4, you're not done, kind of thing. So they have a really hard time tracking what is the progress on site, right? So they're just doing their best to keep up with all the different inputs, to check everything out and then calculate, versus a robot intrinsically, right? You ask it to report exactly where are you, and it's like, I'm 50% done, or I've done 400 square feet because it's what I do. Versus if I ask you to report, you'd have to look around and be like, that wall's a little bigger than this one.
Yeah.
So I think I'm 30% done, but I'm not sure.
Gotcha. That's funny. Yeah, it's nice that you can really improve that reporting process, make it so much better. Like you're like, we are 50% done by square footage, and we have done step 1 and step 2, or something like this. That's really nice.
Yeah, we found that our customers spend like foremen, which are kind of the supervisors, spend 4 hours a week just walking around trying to figure out what the work done has been. Yeah, exactly. That's a hard process to and then coordinate with everybody else around it. Versus, I think this is kind of the exciting future of construction. If you have all of these progress reports, right? That optimization is much easier to say, like, oh, well, we need more painters because they're falling behind.
Yeah.
Drywall's going fast enough. Let's schedule this, and construction schedules can start reducing. Versus right now, because of all the variability, they have to build in a lot of pillows, and nobody wants to get rid of those pillows. So, projects take a long time.
Yes. Gotcha. Very interesting. Yeah, it would be nice to make it more efficient because of those buffers that are built in. You can remove them because you can have really accurate reporting where the robot goes, I know exactly how far I am and exactly when I'll be done. That's really nice. That'd be really cool to, as you guys grow and cover more and more of the whole construction space, you can grab all of those adjacent things and make them really efficient. That'll be super cool. Huh. Let's see. So, we're coming close to the end of this. I'd love to talk about you and your path for a little bit before we end. So can you just at a high level kind of say how you got involved in robotics and then up to your consulting, which then led you here? Or not necessarily consulting, but what were you doing, taking government funding, this kind of thing? How'd you get here?
Yeah, happy to. So as I mentioned, my co-founder, Kevin Albert, founded, we were actually a research company within Other Lab, which is this really cool lab in San Francisco that is, kind of academic lab, but imagine if the output is not papers, but spinning out companies. So they get a lot of funding through research, but take on these challenges that you're just not ready for VC funding, right? It's just way too out there, but say, hey, this is where research money is really great at. Once you figure out what company you want to build, research money is not so great at, then spin out and do your thing. But we had, Kevin and I had originally met at MIT. I was finishing up my PhD and he was at Boston Dynamics. And we, MIT and Boston Dynamics were collaborating on a project for the government, back to the research money. We were looking at making really small robots. So it's a little bit of a different space, but the idea of can the design and the control approach for the robot itself allow you to go different places, right? So these were almost thought to be disposable robots that were really small. And so we met there, kind of connected. It was a cool project because it's so out there. And, for us that students getting to work with Boston Dynamics was also really cool, right?
They're awesome.
He's a big dog. He was working on that and the algorithms for that. So it was just such a cool experience. I graduated went and worked at Lincoln Laboratory for a year, which was, I was just still really excited by new technical challenges as a national lab, right? They get to work on really cool things. So I was working on like design of telescopes and satellites. So I thought it was really cool, but I had a really hard time with the timeline to my project, getting to see the time of day, right? These are like 10-year plus projects because you gotta go through everything to get to launch. So that didn't match as well. But I was moving to California, and you start contacting everybody. You probably anybody who's moved across the country is like, oh, who can give me a job? Talk to everybody. And it was funny that somebody was like, oh, do you know this guy Kevin? He was at MIT. I was like, oh yeah, we worked together. I was like, well, he's hiring. He just got a grant from the government to do these compliant robots. Why don't you connect? So it was like kind of a fun reconnect and be like, hey, I want to move out. I hear you have money. So the stars kind of aligned where he had just gotten money to hire me.
Wow. That's so funny. You're moving out. I hear you have money. That's so funny. Yeah.
Let's be friends again.
Oh, totally.
But it was just really cool because, the vision was there. Once he explained what his vision was of like redesigning robots, right? Not just from a software perspective, but all the way down to the hardware, really rethink robots such that you approach the problem of unstructured environments, right? And he had come from Boston Dynamics. He did that, but he wanted to go a little bit more into a solution for industry, right? At that time, Boston Dynamics was very research-driven still. And so, it just kind of came together. And like I said, we did for 2 years of like just government research. And then once we cracked it, we said, this is it. Let's found it and let's make our company and fundraise. And it was funny. At the beginning, we thought we'd just lease the robots right away. Right? It made sense. But it was listening to our customers and everything that we were like, okay, this will be less friction if you hired us as a service. We can train our own operators. They can sit next to the engineer and complain about everything that went wrong right on that day. And so that's what led us to the subcontracting route, to at least get the machines out there and really make it frictionless for the customers while the machine was getting to, from that prototype to that product stage.
Gotcha. Awesome. Yeah, it's cool to hear your whole story, how it's kind of come, well, I mean, parts of it. It's so, I don't know. It's cool. I've been struck recently by how many companies start by doing like contracting or whatever for government related research, or they start doing government research. And then that's like solving a lot of the problems, kind of as you were mentioning earlier. And then once you find like, okay, this problem can be solved by robots, then you can jump out and do a company around this. So that was the compliance work Kevin was doing. This was, was it this idea of Canvas and the drywall robot, or was it just general and then you found this application?
It was more general. It was really thinking about compliance. And we had gone down to the level where like everything was, air driven. So like the robot was super compliant, which was great for like, we were especially underwater. We were actually hydraulic driven, but you were super compliant. So it was like a really cool approach, but had a lot of technical challenges.
For sure.
But as we started solving, exactly, some of them, it was also looking at each other and be like, okay, we found the application. What do we really need of our research? And that's where it was like, okay, more about the compliance at the end effector. Your whole arm doesn't have to be inflatable for compliance to be there. So we also had to leave a lot of our research ideas behind because they were more research than they were solution solved.
What were some of the challenges? I don't know about, I guess I don't know too much about your past with this, but it sounds like coming from academia to now being in the startup, what have been some of the challenges for you?
Oh, I think the biggest challenge was maybe the mindset shift, right? I loved a lot of academia, but also didn't want to be in academia. So that's why Other Lab and Lincoln Lab was kind of these happy middle steps, right? Because you were still, So I kind of baby stepped into the world outside of academia.
A startup seems like the most into the real world that you can be to me, because it's entirely merit driven for this kind of thing. And can you actually provide value? So it's, I don't know, you're saying baby steps, but then it's like to the bleeding edge kind of thing.
Yeah, there were big baby steps. No, you're right. I think the first two were baby, and then it was like, a giant just plunged.
Yeah, for sure.
I hope you swim. But it always, for me, the excitement was always like building something new or, designing something new and different.
Yep.
There's a lot of engineering that's optimizing and getting it better, either in
Yep.
cost or precision, but I was a little more driven by, I want to create something new.
Mhm.
And so that was kind of the thread between academia, but then also being like, you had to make sure that you were okay letting go of those things, right? And
Of
I
all
think that
the
was the
research
test of,
paths.
that was the real test if we were ready for that plunge, was like, can you guys leave behind the things you don't really need, right? And I think some people can't, and that's hard, right? You develop with research and then you find this perfect opportunity, but then you take that same research solution and try to apply it to the real world,
Mhm.
and it starts breaking on you. Or academia, right? Same thing. Like, that got you a paper doesn't mean it's going to get you
Anything else? Yeah.
anything else. So I think that was a good test for us of like, if we were ready for the plunge, was like, do we really need this arm that we've been working on for, blood, sweat, tears
Yep.
around? And we were like, no, we don't. We can move it to this end and, buy an off the shelf arm.
Yep.
And it was the time to do it.
That's so interesting. It's so interesting to hear that it was like a process of letting go, because you can't carry all this stuff with you. And so you have to, so you can move forward. That's so interesting. It's cool to me how that's like a psychological shift was required,
Mhm.
this kind of thing.
Yeah.
Huh. I would have never have thought of that. That makes total sense, though. Very interesting. And so, coming from academia, kind of getting into this and actually being, I guess, what has your experience been? Like, how have you been thinking of this whole startup time? I don't know. What are your impressions so far?
It's awesome, but it's hard. I tell people who are like, I want to join a startup. I'm like, which one? They're like, I don't know, a startup. I'm like, ooh,
It's a big
I don't know if I
variation.
would do it just for the
The rush
desire
of
to
being
be
a startup.
I think for me it was more like, I want to do this. The way to do it is to do a startup, right? It was more like the venue to do it. And so then it was really cool. I want to be in a company that's solving this problem and everything. Okay, then you have to build it, right? As opposed to, I just want to go through because it does have its hard parts,
Definitely.
right? I think it's also interesting, especially coming from very technical background. Both of us, like, at one point you realize, like, most of our problems are not technical. Right? It's like, we get jealous when the other one gets to do a little bit of technical work, because
That's so
a lot
funny.
of it is like, how do you hire people, right? People have concerns that you have to address. How do you build a company that has good values, and as things get tough, you stand by those values, right? And so those kind of challenges that you're not thinking when you first pick it, right? You're like, how are we going to solve it technically? But as you kind of grow, those become some of the work that you really have to do. And I think there it has to be that you have to be excited about building a company, because otherwise it'll just feel like wearing down. Like, I just want to do, and at that point you might say like, hey, let's bring in somebody to do the company management and I'll just do the technical work. But we both kind of really liked also the idea of like forming a company that we're excited to go into every day. So that's why we kind of stayed in those positions.
Yeah, I really like this, how it seems. So, I mean, to me, it seems like often the best robotics companies are ones that didn't decide to use robotics because, like, they weren't like at the beginning, I'm going to use robotics. They were like, oh, robotics happens to be the best way to solve this problem. And for you with this company, it seems like an analogous thing where it's, I don't really want to do a startup, but it seems like the best way to make this change that I would like to make. I think that's really cool. It's not, and then it sounds like also, as opposed to the viewpoint of I just want to be in a startup, it's a very pragmatic choice, and you are sustained by like a larger mission, which is to make this change to kind of help this area, as opposed to I just want to be in a startup for the startup's sake. It doesn't, I have no greater mission for it. I probably just want to be rich one day, or whatever it is that I think of startups for. This kind of thing.
Yeah, I think some people have this idea of like the payout's going to be great, or I'll get great experience, and that is a really good reason to do a startup. Is you get the
you wear all the hats.
But yeah, for me, it's definitely more like, okay, I get to build this, I get to. But in this end, right, it's like if something is not the way I want it to be, like, it's up to me. Go change it, right? Make the company that you want. So I think that gets me through like the days that are not as easy.
Oh yeah.
And also through the highs keeps you grounded, right? You're also not like, woohoo, all of this is like, oh, woohoo, oh, so much responsibility. I gotta do it right.
Oh, for sure. Have you so in your experience consulting or in academia, did you ever lead teams for this? Like, did you ever lead large groups of people? Because it sounds like you're very involved in this now. And how has that been for you?
I led a little bit, even from in grad school. I always enjoyed kind of the mentoring side. So I had
Yeah.
like undergraduates
Mentoring's
that worked
great,
for me,
for sure.
but you know, one or two,
Yep.
yeah, one or two people, and it's a little different, right? Because
Yep.
it's smaller scale. You can spend the time. So I knew I had enjoyed that. I'd done like class projects and been kind of the lead. So I was happy to go that route, right? Like
Mhm.
I was like, I want to manage versus other people very quickly. Like I'm an IC,
Mm-hmm.
I'm great at it, right? But that's what I want to do. And if you come in with that self awareness, it's always a lot easier as a founding team, right? If everybody knows.
Mhm.
But once I started at Other Lab with Kevin, right, it was like I think him, myself, and another person to start, and then we started growing. We needed more engineers, and he was CEO, so he was running kind of this part, and I just kind of said to him like, "Hey, you cool if I start managing this group, right? We're starting to get a little unwieldy, and we have to get like things like that."
Yep.
And he was like, "Yeah, sure, go
Of
for it."
course,
So
yeah.
it was
Happy to
kind
have
of
you.
this gradual, and I got to grow with it, right? Because at first it was like 3 reports,
Yep.
and then 5, and then 20, and then you're just like,
Yeah.
all of a sudden you're just like, okay. It all kind of allowed me the time to grow with it. I imagine some other companies have these humongous steps, and
Oh, totally.
I mean, you
That'd be
just
really
kind of go
rough.
with it. Yeah. So far, it's allowed me to grow it, and then the other piece has been like, what areas are you weak on? Get somebody.
Yep.
Just be very self-aware throughout the whole journey, because otherwise you'll just kind of hit your head against the wall and be frustrated when you're just gonna, I enjoy this, or I'm not that good at this.
Yep.
Either get training, get a coach, but also probably get somebody within the company to help you with that
Yeah.
side of things.
For sure. Yeah, I think being really realistic and being like, I'm good at this, I'm not good at this, and thus addressing whatever it is. Like, I'm good at this, I'm going to do more of that. I'm not good at this, I'm going to hire that out. These kinds of things. I don't know. A very deep connection to reality seems like a really important thing to a startup's success, in my opinion.
100%. Yeah.
Mm-hmm. What would you, so advice for like a 20-year-old you or something like this? Like, what advice would you give to someone who's like 20 now, just starting school or in the middle of school?
Yeah. From the technical side, I would say like explore outside of your domain, right? Robotics in particular requires that cross domain, but I think in general we're just seeing more and more like jobs blending, right? I don't think there's very few people who do only one thing, right? And so I would say explore. Really, even if you have mechanical engineer, take some software classes or even sit in on those. Like get yourself in there, do some projects that maybe expose you to that. And then that'd be the other side of like, I was lucky and I'm just interested in business, so I'd taken some business classes at MIT and participated in some of the entrepreneurship center work. But that exposed me to it. So I think for people who are thinking like, hey, maybe I want to do a startup, there's a lot of opportunities to dip your toes while in college into it, like, learning about business plans and stuff like that. And just kind of see back to that realistic, like, maybe that's not for you. You might be really happy in a big company or something, or, a big national lab doing just research or academia, but kind of go out there and test it out rather than I think sometimes, you get like, you hear the latest thing and that's what you're going to do. And you're just, I'm now going to be a founder. And you're just like, don't know what that means.
Totally.
So it's a lot about experience using that time in school. It is about getting the grade, but it's also about like what awesome opportunity of 4 years to just experience like the lectures that you get to go to, right? That you're just never going to have the time to do that kind of exploration. Like do it then and
It's true.
Get to know really who you are, back to that self-awareness. The more you discover it, then the less, at 30 is a lot harder to be making yourself aware.
For sure, with all the life things that come up. Yes,
Exactly.
for sure. Huh. Okay, awesome. So if you look out like 2 and 5 years, where do you think robotics is going to go?
I definitely think that there's going to be a huge growth in other markets, if you will, or other areas, right? I think logistics and manufacturing will continue to kind of increase, but to some point we're getting to like the optimization problem rather than the adoption problem. And I just think areas like construction, but there's so many other ones are really need that kind of productivity gain. We always look at that plot. If you plot like manufacturing productivity versus construction, manufacturing went like 300% and construction decreased. So we've actually gotten less productive over
crazy.
time.
And it's regulation,
and so that just,
isn't it?
I think it's, regulation, right?
Not
Which
saying
is
it's bad,
overall,
but just
exactly,
like it,
regulation. And then don't give people new tools. So you say, I'm going to make it a little harder, remove, people used to use stilts, for example, to finish ceilings. Say, that's not very safe.
yeah.
I'm going to remove that, but you still have the same tools.
Ah,
What's going to happen, right? Or even the designs got more interesting. People,
sure.
architects got cool designs, but you still have the same tool from 50 years ago. Something has to give, and productivity is what's given. And so for me, I really see robotics, especially with the sensing technology that we've gotten and the computational power, but also the approach. If people start approaching them differently, right? More the cobots, more the augmentation.
Oh, yeah.
I think you start opening up the idea of like, okay, maybe a robot is not a fixed equipment, but a tool. I just see that really exploding and people really being able to, protect their bodies more by having access to these tools. That all of these kind of things are coming together at this time. So I don't think it'll be just construction. Construction will be one of the big ones, but some of the other spaces will also get really interesting.
Awesome. Now, do you have any links or contact info you'd like to share with our listeners and watchers?
Yeah, we always encourage people to go to our website at canvas.build. And yeah, you can reach out over, LinkedIn or over email. It's just maria@canvas.build. But we're always, excited. We also have an Instagram that we tend to post a lot of pictures on site. That one I like because you get to see the reality, right, of like what it's like. You can see those nice pictures where everything's clean and the robot's there and it's beautiful. And then you see the ones where there's buckets everywhere that you're looking around and you're just like, oh, that's why it's hard to be in an unstructured environment.
Yeah, for sure. Oh, that's so funny. All right. Hell yeah. Well, this was a blast. Thank you, Maria.
Thank you so much. It was fun to get to talk to you.
Awesome. Bye, everyone.
I hope you enjoyed my conversation with Maria Telleria. Thank you again to our founding sponsor, Open Robotics. See you next time.